Good morning, student. This is me, Kazi Azimul Haque, assistant teacher, Cantonment Public School and College. Today we are going to learn about a very new chapter of physics. That is the name of the chapter is motion, and the topic we are going to discuss that is different type of motion. We know there are different kind of motion in the earth. We see it, we observe it, but we actually not going to have it or learn it. As usual, we are actually thinking it's a kind of motion, but whenever we are going to learn it, whenever we are going to watch it, actually what is the differences between that motions, if we learn it, we can clearly understand it. So today, as we are going to learn, that is different type of motion. Have you ever seen our needle of the watch, hand watch, like the needle of the clocks of the wall, like when the car is moving? So everywhere actually, if we try to think or we want to see what kind of motions are there, we can actually find out the differences. What are the differences actually that lies in the different kind of motions? First of all, there are some kinds of motion. They are like linear motion, they are like linear motion, they are like circular motion, then translational motion, periodic motion, and simple harmonic motion, etc. There is also some of the motions named vibratory motion, only harmonic motion. So according to our books of class 9 and 10, the first one is linear motion. Actually, what is the linear motion? Whenever the time we are actually going on, we are running on the road in a line. Line is two different. The line has two different types: the bended line, the straight line. But whenever we are going in a straight line, and our motion is on the way in a straight line, that is the linear motion. That is the linear motion. But if anybody is going to ask me, sir, what is motion? What is motion actually we are thinking about, we are talking about? So motion is like something which is changing its direction, its displacement in any kind of direction from its initial position. Like we can think there is a point, this point is going to cross in the difference of time. Whenever this point is going to pass that point in respect to time, then I will say this point is in a motion. Whenever any object is actually just changing its position with respect to time from its initial position, that is in motion. So according to the linear motion, whenever any object is just changing its direction, changing its motion, its displacement in a certain direction with a line, that is the linear motion. Whenever any person is running in a straight line, that is straight way, that is straight, that is a linear motion. Whenever a car actually going in a straight way, that is a linear motion. The motion of a car, that is a linear motion. That's the example of linear motion. Now circular motion. If we actually find out our surroundings, we can find whenever a car is moving, so how the car's wheel is actually going on. The wheels is doing, what is the action of the wheel of the car is actually on the car. So if we want to see the ceiling fan, so we are very familiar to the ceiling fan in our houses. So whenever we put it on, the ceiling fan is moving and moving and moving, but it's moving and changing direction without changing its actual position with respect to the whole surface. So it means like whenever any object, we can say like this, whenever any object is not changing its actual position and it's moving with respect to a center of a point, then that should be a circular motion. Whenever we actually putting on the fan, the ceiling fan, it started to move on. Whenever the car starts to go for a while, then we see the wheels are moving. Wheels are not actually displacing its position with respect to the car, but the wheels are moving. That's why the car is going on. So the motion of the wheel, the motion of the needle of the watch, the motion of the fan, that is the circular motion. And if you want to know about the circular motion, there is a very good example we can see, that is the moon. The moon is actually moving around the earth without any kind of connection, without any kind of relation with the earth, and it's going round and round and round. That's why we get the month which is related to the moon. So that is the circular motion. Now translational motion. Actually, translational motion, if you want to disclose it, we want to discuss it, we have to know, or we have to learn some of the motion where they are actually moving like a robot. What does the robot do? The robot actually walks and suddenly it changes position. So whenever it's changing its position, the point of the changing its position on the direction, there is no bending ways. Without the bending ways, like you can see it over here, I can actually show it on the board. A point is moving like this. So every single way it's actually changing its direction like respect to the geometrical angle. But whenever a car is like moving on the field, someone is trying to learn the driving, so how does the new driver will learn? You will like drive the car like these. So if you want to find out the differences, that is, here is every single time it's changing its direction in different ways, then it got a certain direction. But here, one single displacement, one single direction, one single displacement, one single direction. So translational motion I used to give you to learn like the robotic motion. Whenever the robot is actually walking, a robot is actually walking, we have seen several times in the TVs and kind of shows, like the robot is actually walking. So whenever it's changing its direction without any kind of making a bending actually path on the taking another direction. So that is the translational motion. Now periodic motion, it's a very simple one, the periodic motion, actually whenever anything actually moving in a circular motion, but it is every single time whenever it is crossing a certain direction, that is by maintaining a certain time. We can show over here, whenever an object is moving with like crossing this point every time, so starting from here is going back to that point, it is taking 2 seconds. Again it's passing that point by 2 seconds. Again it's passing this point by 2 seconds. So if you look at this place, you will find out that every single time the object is crossing point A by maintaining 2 seconds. So as it is maintaining the time to cross a certain point, that is a periodic motion. all periodic motion is like a circular motion, but like circular motion, the circular motion can be periodic motion. Understood? This is the periodic motion. And you know, simple harmonic motion. Whenever I am going to learn, going to teach you, actually with the simple harmonic motion, I used to say the example of pendulum of the wall clock. It's like a pretty old clocks, actually is very famous in the previous time in our country. So whenever the pendulum actually did on the wall, so what is like that? I'm going to show you. If we think, we are assuming this is a pendulum and it is hanging with a clock. So what is happening? Just take a look. So whenever actually we are thinking that this is the highest point and it's going back and coming again in the point, it means this pendulum is going in a certain direction. After a certain time it's coming back to the previous direction. So it means that whenever any object is moving in a direction by maintaining a certain point, it will move at a time, it will move in one direction. After a certain time, a fixed certain time, it will come to the previous direction again. In that time, in this case, we will say the motion of that object is a simple harmonic motion. Now, simple harmonic motion is like whenever actually the pendulum is maintaining the time, like the periodic motion, and also it's changing its position, direction from one direction, fixed direction to the previous direction, then this is the simple harmonic motion. And the example of the simple harmonic motion is very easier one I'm going to give you, that is the pendulum of a watch. Sometimes, you know, people used to, some of the technical people, they used to hypnotize the person with the bob, like a pendulum. It's also like a simple harmonic motion, Now, there are some of the another motions, you know, I have written over here etc, like vibratory motion. Vibratory motion is like simple harmonic motion, but there the time will be not maintained by the particle or the object whenever it is moving its direction or changing its direction, and it is giving you the motion. So that is the vibratory motion, and some of the other motions over there you will learn it properly in higher classes. So if you are going to look over here, a good look on our today's class, that is there are some of the some kinds of the motion. They are like linear motion, circular motion, transitional motion, periodic motion, and simple harmonic motion. They are also like the vibratory motion, as I have mentioned. So if we see our book, the book is also actually mentioned it properly. So we are learn it, we have to apply in our physical life. Whenever we are watching some of the motions, if we are going to try to learn what kind of motion is this, we can easily find it out. So hopefully you have enjoyed the class and you have learned something new, and it is going to give you a good feedback in your next class, inshallah. So see you in that class. Best of luck. Allah Hafiz. Assalamu alaikum.